morning everyone. With due progress of structural geology, nowadays science has developed into a new era of analog modeling and mathematical deduction derivation. But in the light of that, sometimes we can see in normal college or universities BSc curricula, in those curriculum the block diagrams, the importance of three-dimensional ideas by calculating the true deep, apparent deep relation in block diagram, in plan view, in section, those concepts has been quite reduced because of the reduced part assigned for those exercises. Therefore, as I am a professional of Geological Survey of India, I find during exploration or during mapping, these concepts are very necessary, even in field also. When we only see some parts of the exposed beds in plan view and very little sectional view or oblique sectional view is present, then those exercises really help to determine that which way the bed is actually digging or which way the foliation is actually digging. For that, step-by-step exercises are needed, and that is why today I am here with the basic geological exercise of structural geology practical, which we did in few first classes of our BSc base. So first exercise will be how to calculate apparent deep from true deep without using any stereomet, and next exercise will be how to calculate true deep with two apparent deeps, any random apparent deeps of any plane. So that is the exercise for today. And while explaining those things, before we need to clarify the concept of strike line, stratum contour, and true deep and apparent deep. So first I am drawing a cube, and because I am doing this exercise for mainly BSc students, I am using scale. This is the way you have to draw a cube. Centimeter is the length of sides. Since I am not using pencil, so with the line thickness is given 1.5 millimeter. So some discrepancy in result can come, but mostly I will be concentrating on the theory and on the main hypothesis and logic we should apply before going for such exercises. Now for drawing a cube, suppose this is the cube. This is not a cube, but similar to a cube. So suppose you are observing in three-dimensional figure, this face is this one, the top face is this one, and this face is this one, and other three faces, bottom face, rear face, and left side face are hidden. So now if we want to draw a plane, an inclined plane, suppose this is the inclined plane. You can observe through it since it is transparent. This is one inclined plane, suppose. So to draw it, how to draw it in 3 dimensions? To draw it in 3 dimensions, So in three-dimensional figure, this plane is represented by this blue line. If we want to highlight, we have to place just some dots on that plane. There are some dots on that plane. So this is the three-dimensional plane. Now, what is the definition of strike line? Strike line is the line which is horizontal and is lying completely on any inclined plane, or in other words, strike line is the line of intersection of any inclined plane with any horizontal plane. Suppose this is the inclined plane. Strike line on that will be the intersection with the horizontal plane. So suppose I am imagining one horizontal plane through this, so it will intersect with this inclined plane, forming this straight line, straight horizontal line, and this is the strike line. So to show in three-dimensional block figure, if we can draw one horizontal plane, this is the horizontal plane, this one, and in rear face, this is the horizontal plane. Suppose cutting this inclined plane, it will intersect through this line. This is one inclined plane and this is one horizontal plane. So this horizontal plane will intersect it like this. This is the horizontal line. So here the horizontal line will be this one on the plane. So this line will be called strike line, and suppose this is 0 meter. Suppose this level is 0 meter and this level is minus 200 meter. We are going downward. Now this will be somewhere between, suppose minus 90 meter approximately. So this is the strike line, minus 90 meter strike line, this one minus 90 meter, because at minus 90 meter the horizontal plane is intersecting this inclined plane and this straight line, straight horizontal line is generating. So the line represents minus 90 meter strike line. But in 2D, when in a copy we used to draw, we used to solve the problems, this is 2 dimension. This is 2 dimension, and this figure is 3 dimension. So for convenience, from 3 dimension we have to project the things on 2 dimension. That is the plane of paper or the whiteboard or blackboard, anything. So for this, generally we live on the surface, this surface, this top surface, or as per this, we live on the surface. This is the surface. So generally we do the plan view work, this top to bottom. Suppose I am watching this surface from top, which we do usually, that is the plan view. So we have to do maximum work or maximum projection in this surface only, because the rocks are exposed in this surface, on this surface. So we have to project everything on that surface with the help of few sections. Suppose this is one vertical section, this is one vertical section. With the help of these sections, vertical sections or oblique sections, suppose I cut this cube diagonally, the plane it will make, this will be my hand, this will be on oblique vertical section. So based on this section we get the data of inclination and data of depth, and then we project these things into the plan, and we construct plan on 2 dimension. So the basic funda is we have to project this straight line to the surface because it is 90 meters below the earth. So we have to project it onto the surface. For that, what we have to do? There are many kinds of projection actually, but now we will project this straight line just vertically above where it intersects the surface, and on the other end we will do the same. And this line, projection of this line, straight line on 0 meter plane or on surface is called stratum contour. Since it is stratum contour of minus 90 meter straight line, so we will call it specifically minus 90 meter stratum contour. Now the funda of true dip. True dip, the definition of true dip is the maximum dip one inclined surface can have. That is called true dip. So the true dip actually happens to be on the direction perpendicular to the straight line. Suppose this is the inclined plane. Inclination can be measured from anywhere. Dip means inclination of any plane from horizontal. So this is the horizontal level. You can see this is the horizontal level. So from there the inclination, it is having the angle of inclination, and if you see here, this is the horizontal level, this is the angle of inclination. Now it can be measured in n number of lines. It can be measured in this way, from this to this, n number of lines. On n number of lines it can be measured. But true dip will be the only maximum value, and that will be on the perpendicular direction with the straight line. So here the straight line is this one. I have explained, this one is the straight line. So just perpendicular to that is the true dip. Since here these two planes are perpendicular and I am fitting this inclined plane into that, so this is the straight line, and perpendicular to that on that plane, this is the perpendicular plane. So this angle is true dip. So true dip definition is the dip or inclination of an inclined plane measured on a vertical plane perpendicular to the straight line. Measured on a vertical plane means this is one vertical plane. Suppose this one is one oblique plane. On that plane, if we measure the angle between these two, it will give different result. So measured on a vertical plane, the dip of any plane or inclination of any inclined plane from horizontal measured on a vertical plane, that is perpendicular, essentially perpendicular to the straight line, that is called true dip. And the n number of dip or inclination which are possible on this inclined plane are called apparent dips. Suppose now on the strike line I am measuring, this is true dip for this plane, this is the true dip, here it is maximum, now it will be reduced, and you can measure also by practically doing this thing at your home with some home stuffs, and you will see that along this line, if you measure it from horizontal level, this angle, if you measure this angle from horizontal, because you have to construct another vertical plane, dip can be only measured on a vertical plane, so you have to construct a vertical plane through this line, and then on that the value will be less than true dip amount. True dip means you have to measure it, this is the true dip direction, this is the horizontal here, so this angle will be the true dip. So by this way, true dip, suppose here the dip is 30 degree, here it will be 15 degree. By this way, parallel to strike, when you will measure, because its strike line is on horizontal line, so on a horizontal line, everything, every point is on same level, so there the amount of apparent dip will be 0. This is a question actually for BSc first year. Along the apparent strike line, what is the apparent dip of any inclined plane? The answer will be 0. So this is the major concept of true dip, apparent dip. And one more thing, this distance, this is 0 meter. So this strike line is a constant line, means parallel line. Any inclined plane which does not rotate or is not folded or distorted, that inclined plane will continue with the same dip or true dip. So the orientation of horizontal line on that inclined plane will maintain a constant direction. Suppose this is, or they will maintain a parallelism, means if we construct one plane on minus 190 meter horizontal plane, that will intersect this inclined plane along this line, so this line will be called minus 190 meter strike line. So minus 190 meter strike line, minus 90 meter strike line, minus 100 meter, n number of strike line will have a parallel relation or constant orientation. So this is also parallel to this line is also parallel to this, and it is on 0 meter. So we can consider this line as 0 meter strike line. This line. This is 0 meter strike line, this is minus 90 meter strike line, this is minus 190 meter strike line, this one will be minus 200 meter strike line. So strike lines are all parallel. But what varies? One thing varies. They are parallel. Angular relationship is same. They are parallel. But the strike spacing varies. For 0 meter strike line, the strike spacing is 0. No deviation from this line. For minus 90 meter, this is the strike spacing. This length we call strike spacing. Strike spacing between 0 meter and minus 90 meter. Stratum contour. These are the projection of strike line on the plane or surface is called stratum contour. So if we project this one minus 190 meter in this way, so it will form one line of this one. So this will be minus 190 meter stratum contour. This is 0 meter stratum contour. This is minus 90 meter stratum contour. This is minus 190 meter stratum contour. So this strike spacing is very important thing. Now suppose roughly I am drawing another cube. Suppose the depth of this inclined plane I am measuring with diagonal scale is 10, 20, 30, 40, 42 degree. 42 degree, moderate degree. This angle is 42 degree. Means this angle, to draw one analogy, this angle is 42 degree. Now suppose I am increasing the deep amount. This was 42 degree, I am increasing this one to 80 degree. I am trying to draw. This angle is 80 degree. I am trying to draw this plane. This is another face of cube. So this is the plane. Now suppose after this is 0 meter, after going minus 90 meter level, I am imagining one horizontal plane. So it will intersect this inclined plane, that will be the minus 90 meter strike line. We have to project it to get to the surface to get the minus 90 meter stratum contour. Here it is the minus 90 meter stratum contour. You see the spacing. Here the spacing is much more, 0 and minus 90, and 0 and minus 90. Here the spacing is small or less strike spacing. Here strike spacing is larger. Now with another block or another cube, if I draw one plane which is dipping with 20 degree. Suppose this is the plane dipping with 20 degree angle, and again at minus 90 meter I am trying to imagine one horizontal plane. So the intersection will be here. This will be the strike line, minus 90 meter strike line. So if we project it to the surface, this will be the minus 90 meter stratum contour, and this distance, this strike spacing is very large, right? So here the deep amount is 20 degree to deep amount, here 42 degree, here 80 degree. And if we arrange this from large to small, this will be number 1, this will be number 2, this 0 to 90 meter strike spacing, and this will be number 3. And can you correlate here? Means if I compare the strike spacing of 0 meter and 90 meter and column wise with 2 deep amount, here everything else are constant. Deep direction, every strike of the bed, everything is constant. So where it is 20 degree, this is highest, where it is 42 degree, this is moderate, where it is 80 degree, this is lowest. So this strike spacing actually varies, and it shows how close are stratum contour. That means close stratum contour means small strike spacing actually means the bed is steep. Steep means high angle of dip, and gentle means low angle of dip. And very large spacing of stratum contour means the bed is very gentle or having very low angle of true dip. So this is the logic. We cannot construct on 2 dimension what is in depth. Suppose this is in depth, and in plane of paper we draw generally surface in plan view, so we cannot show the data of dip on the plan view in 2 dimension. So what will be the representative of that dip on the 3rd dimension? That will be the strike spacing. If the dip is more or very high, then the strike spacing will be very low,
and if the dip is very low, then
it will be very high. So this is one thing. This logic we will be applying during future block diagrams or calculation of true dip and apparent dip.